Hello everyone, welcome to Virtual School Physics is Fun. Juan Liao says hello. Today's topic is refraction of waves. What is refraction of wave? When wave travel from one medium to another medium, its speed will be different. Okay, so because of these changes in speed, light or sound or water wave will bend. Okay, I repeat, yeah. So refraction is actually bending of waves when waves move from one medium to another medium because the speed of these waves changes. Different medium, the speed will be different. Okay, so for light, the different medium will be different optical density. For example, from air to glass or water. Right? So different optical density. As for water, it will be different mediums. The different mediums means different depth, from deep region to shallow region, or the other way around. For sound, it will be from different medium of different density. Yeah, for example, from the air to the sea to water. Okay, so different density. Now, what happened after refraction? We have just learned that different density, the speed will be different. Therefore, after refraction, the speed is different. The speed changes. Direction change because bending of wave, right? So the direction changes. Wavelength changes too. Okay, we will look into this more into more detail, as in wavelength. So for the time being, we know that refraction changes wavelength, but frequency remain the same. Okay, refraction of light. Okay, all right, from a less dense medium to a more dense medium, the speed of light changes, so therefore light bends. So let's see how it bends.
First encounters a piece of glass, one side is slowed down before the other, forcing the wave front to change direction. This bending of light, whether in glass, water, or any other transparent material, is called refraction. Light is refracted closer to the direction perpendicular to the interface whenever it enters a medium that slows it down. This occurs no matter what the direction of incidence.
So from here we have seen that for light, when it travels from a less dense medium to a denser medium, it will be bent, it will refract, towards normal. And conversely, if it is moving from a denser medium to a less dense medium, example from glass to the air, the refraction will be away from normal. The direction of refraction will be away from normal. Okay, what about water wave? Now for light wave, if you want to learn more detail, you look up for the video, my video on refraction of light wave. Yeah. So for this video, we are going to concentrate on refraction of water wave. Now, just now we say that for water wave, the different medium means different depth, right? So speed of water wave will change as the depth changes. In a deeper region, water moves faster. Speed of wave is faster in a deeper region than in a shallow region. When water waves move from water of different depths, the speed changes. So because of these speed changes, the direction changes and refraction occur. Okay, let us be reminded that in a deep region, water wave speed is faster than in a shallow region. That's why we always say in the deep end of the sea is more dangerous than in the shallow end. Okay, simply because in the deep end, the speed of wave is faster than in a shallow region. Okay, let's look at this graphic here. So you can see this is a deep region and this is a shallow region. You see how water wave bend, right? So propagation of wave is always 90 degree. Yeah? It's always perpendicular to the wavefront. All these are the wavefronts. Okay, so it's 90 degree. So you see wave is propagating to the right, and as it enters the shallow region, you can see that the wavefront has changed. So therefore, the wave direction also has changed. Yeah, 90 degree. Other than this, we see that in the deep region, the wavelength, this is a wavelength, yeah, from one wavefront to the next wavefront. So this is called wavelength. So the wavelength in the deep region and as compared to the shallow region is different. So wavelength in the deep region is longer than in the shallow region. All right, so wave bend, so direction changes, and so is the wavelength and the speed. Okay, now for water waves, when it moves from deep region to shallow region, you can see that the bending is towards normal. Conversely, if it is from shallow region to deep region, the bending is away from normal. So this is normal. So if it does not bend, it will be this dotted line. So now it bends away. It moves away from normal. This one, this is a normal here. So if it does not bend, it's this dotted line. So now it bends towards the normal. Okay, so the bending is this one. Let's view this video. Now, before that, in the school, how do we carry out an experiment to study water waves? All right, so we have to bring in an apparatus so that it enables us to study water wave. So how do we create a shallow region? So a shallow region is created by submerging, fully submerge a piece of glass or anything transparent into the vapor tank. Okay, let's view this video. See, a piece of transparent object is fully immersed, make sure fully immersed in the water. Okay, in the water of the vapor tank. Right. So this is the wavefront, the incident wave. This region will be the shallow region. So above the glass, the water is shallower. So this is a shallow region. This is a deep region. This is how we create a region of a shallow region in a vapor tank. Okay. So the resolution here is not very clear. A little bit. You can see here this wavefront, this direction, and then this one. You see the wavefront bend. So the wave direction is bend. Okay, now this is a cross-sectional area, so it shows the vapor tank. So this is the glass or the any object that is transparent, for example, perspex that we fully immerse in the water of the vapor tank. So the area above this perspex will be shallower as compared to the this region and this region. Okay, so this is the deep region, this is a shallow region. So from here we can see that the wavelength in the deep region is longer than in the shallow region. Okay, all right. Now characteristics of refraction of waves. So frequency remain the same. Wavelength in the deep region longer than the shallow region. Speed in the deep region is faster than in the shallow region. And the direction, of course, changes. From deep to shallow is towards normal, and shallow to deep is away from normal. All right, so we will continue with phenomena of refraction of waves in our daily lives in another video. All right, so do look out for this video. All right, thank you. Bye bye.